I hope we got some basic understanding about the dialysis procedure and the different disposables which are used. Now we are going to see a live demo of how to prime a dialysis machine and the various functions with this particular Fresenius 5008 machine. With me is Mr. Mahmood Maqbool. He's been dialyzing patients for the last 23 years, extremely experienced, and I don't think that there is any dialysis related problem that we haven't seen. So he's going to tell us how this machine is going to work. So first of all, we're going to turn the machine on, and you'll see these lights. Now these lights they change color from red, amber, and green. Red is also when the machine begins to alarm. So the red, it's just like a red light where it tends to blink. So that's what you get. Now, once you've turned the machine on, the machine is going to take about 15 to 20 seconds before it starts to begin. And so far, you can see the light, it is still red. Now it's turning itself on. This tells you that the power supply is working as well. And it gives you that the software version as well as the type of. So this is a Fresenius 508S dialysis machine. Once it takes about 30 seconds to a minute. It checks itself, and when it is on the amber means that the machine is ready to be primed, but not to be connected yet. So this is to be primed. Once you connect the patient, this light is going to change to green. And if there is a problem anywhere during the dialysis procedure of any kind, this will change to red, and then it is going to flicker. So we've got two on the screen. We can see the different things. We've got standby, status, info, etc. So different one, blood system. Then we've got pre. So over here we've got preparation, we've got dialysate menu, UF menu, all of these things. But what we need to do is we have to select one of these two. Either we go on the treatment mode or we go on to the heat disinfection mode. So we'll go on the treatment mode, but before that we are going to prime the machine first.
Test machine.
So we are going to now test the machine. We've got the acid part, and in the other can we've got the bicarb which has already been made. Now once you put the red goes in the acid part. The blue will go in that part if you're using the can. If you're not using the can, if you're just using a buy bag, you don't have to use this one because this is only meant to be for that one. Now once you've connected that, these two, this machine is now going to pass its test. So we call it passing test. One of the critical steps, because this is where if there is a fault in the machine, it often fails. The machine wouldn't let it go any further, so it won't pass a test. So now the machine has gone onto the test mode. It is going to suck up the acid. It is going to mix that with this one, and as you can see down here, it is now mixing with it, and it is swelling up. So the bibag is swelling up, and the bicarb solution is now being made. This the machine is doing automatically. That one was prepared by us earlier on. While that is happening, we are going to connect the dialyzer because the machine has to do everything. And as I've said, so the dialyzer we're using is a 1.4. It's a Baxter dialyzer, and this goes on the side. And now we've got the BTL or the blood tubing line. It is composed of two parts, as you can see. One is the red, one is the blue. The red is arterial, blue is venous, but the red one obviously brings the bad blood from the patient. The blue is the one that brings the good blood from the machine towards the patient. Now, a very important step that you have to see in this one, that where do you connect these ones? A BTL is one in which you've got the blood. And remember, the blood actually goes underneath. So it connects down here. In these two, you've got the dialysate flow. And they go in a countercurrent fashion. So the blood goes from here and it comes through the other side. The dialysate flow comes from here and it goes on that side. And so they have to run in a counter current fashion, in this fashion. If they both went together, then you won't get any clearance. You will get clearance, but it will be ineffective clearance. So if you've got a patient who's not clearing properly, always make sure that these ports are fitted in properly. So they have to be in a counter current fashion. So this one goes here, and the dialysate is going to go on the other side. This connects there.
Open the door.
Open the door. This one, the port goes here, and that's the pump, the driving, the central pump, which is going to drive the machine. So once you've connected that, the machine, obviously, it tells you what is happening. So it tells you all along. So the machine has told you that the dialyzer has been connected. The machine tells you that we've got this as well. Now this is the this is called as a TOM sensor. Very, very important TOM sensor. This is available in these machines only, and this makes these machines unique in that way because this measures the arterial pressure. Arterial pressure, if it falls because the person is hypotensive, or if there is a problem drawing blood, if the person has got a bad access, this machine is going to alarm, because this sensor is going to pick up any fluctuations in the pressure. So these are all pressure sensors. So this is going to pick up any pressure problems. So once we've connected that, machine has told you that this has been connected. It still hasn't gone in. And we connect the blue side, which is the venous one, and we'll see that this goes on the top.
Venous sensor pressure.
And this is the venous sensor pressure. This one you can apply that with a filter. You can get filters along with that as well. So you can apply that with a filter, and that gives you added protection.
Optical sensor.
This is the optical sensor. Now what the optical sensor does is it makes sure that there isn't any air in the circuit. If there was air in the circuit, then this is going to alarm and the machine is going to stop, because it's very important there isn't any air in the circuits, and this is what it's there for.
That is complete.
When the set has been placed,
TOM sensor pushed.
the TOM sensor, if you see closely, this sensor has gone in. This sensor has gone in from the side, if you can see. So this has gone in, and when it goes in, it means that now it is working. And this screen shows you that all the circuits are now complete. So the red circuits are now complete. So the bicarb, the bibag is attached. So that is complete. The dialyzer is complete. So all of the circuits are complete now for this one. We attach the normal saline. We have to prime this system with normal saline, as if, and this is a connector with it.
With BTL.
And the normal saline connects with the blood tubing line. Now if you see that this part of the blood tubing line is the shorter part, this is the part that is actually the other one. So this is the red part, so it has been connected to the red part, and this will be connected to the patient as well once we've primed the machine.
All set complete.
So once all of this is complete, now you go on preparation. Once you click preparation, you see there is a for the blood pump. Remember, the door has to be shut. If the door is open, the machine, it won't work. So the door has to be shut. Now the pump has started. See, all along it tells you that all the systems are working properly. And as you can see, the machine is now drawing saline here. So saline is going through here, and you can see air bubbles here as well, because obviously there is air in the saline. And it tells you here that you've got a rinse volume, you've got a pump speed. So this is the pump speed, and the pump speed is currently at 200 ml per minute. When we start dialysis, we usually start at a lower pump speed, because we don't really want to overburden the heart. Because if it's 200 ml per minute, and that's a pretty decent flow rate. If you increase that initially to about 250 or 300, obviously it's going to overburden the heart. The heart has to go along with the machine, with the pump. Now this is a machine. The heart is obviously, these are dialysis patients. The heart is weak, so therefore they can go into serious problems if you increase that straight away. So once you're priming, usually it's about 180 to 200 ml. So now you see that the fluid is going out, and the machine, the blood tubing line has now been primed.
Recirculation.
And now you connect it with this one, and you leave it like that, And now this circuit has gone on a recirculatory mode. So now all of this is going to, now this is ready for the patient when the patient comes in. And you can see that it's measuring the arterial pressure. You've got the venous pressure, which is being monitored. So the machine is checking all of its system to make sure that all the sensors are working properly. It has also picked up the dialyzer, and we can use any dialyzer which we think there is. The machine obviously changes its setting, and you've got the prescribed bicarb. As I said earlier on, that bicarb is important. It's sodium bicarbonate, and you've got different variations in how much bicarb you can use per patient. So if you want to give them more bicarb, you can change it from here. Currently it's 31, so this is 31 millimoles per liter bicarb that is going in. So if somebody is acidotic, somebody is hyperkalemic, you probably want to give them a bicarb, and so therefore you can increase the bicarb value. This is the prescribed sodium. Now this is critical because sodium means conductivity. You often hear the word conductivity. What is conductivity? Conductivity is actually sodium, the prescribed sodium. The person has sodium in the blood. If they've got heart failure, they're fluid overloaded, the sodium will be less. There's excess water, but there is less sodium. You don't really want to give them excess amount of sodium because it's obviously add on to their water problems. So you want to keep that at the base, and the base is, say for instance, it's 134 millimoles per liter is the base which you want to give, and that's how you can quickly and you can draw fluid out of the circuit. But if they are hypotensive, if they come to you with hypotension, they haven't got cardiac failure, but they're just hypotensive, you want to give them, add on a bit of more saline, a bit of salt, then you increase the conductivity to, over here it says prescribed 140, so you want to go slightly above what is present in the blood. So if the sodium level in the blood is, say, 134, and this person is not in heart failure, and you want to give them excess sodium, all you have to do is, instead of the base 134, which you call as a base conductivity 134 sodium base, you can increase the sodium to 136, 138 if you want to give them salt. If you want to remove salt, you think they're overloaded, you think they're extremely hypertensive, you think they're all of the problems, you want to bring the conductivity down. So 134, you bring it down to 132, but never below 130, because see, that is going to be detrimental. There'll be a lot of sodium shifts. You don't want to do that. So my advice is 132, don't go below that. You can change the bicarb setting, and that's important because bicarb also obviously causes hypotension, but do not change the sodium setting to below 134 and never go above 140. So stay about 134, 136, 132, but never beyond that.
Concentrate setting.
So this is the concentrate setting. Now what we see here is, we see that we've got different concentrate settings. Now it's extremely important that this machine has picked what is in the can, the A part. So if you look at here closely, you'll see sodium 140, potassium, these are exactly what's there on the label. These are the things which are present. It's got magnesium in it, it's chloride in it, it's got bicarbonate. So it's got all of these things which are happening right now. So the machine has picked up from that, and then it has now given you an idea that I've got all the information which I need. What do you want me to do? And that is where you're going to change the settings. These are the two settings which you change, either the bicarb or the sodium setting, conductivity, which I've just told you, and obviously the water which you want to remove from the circuit.
Conductivity.
Now here we are. So this is conductivity 13.2. Now 13.2 basically means 132, 133. So 13.3 in simplified means 133. So sodium is now 133, sodium was 130, now it's 134, and so therefore it is going to change the conductivity, and it really depends how much you want to prescribe. Here it says prescribed sodium is 140, so it is going to change itself.
All test clear, only conductivity test.
So we're just waiting for the conductivity test. Once the conductivity test is clear, so now it's 13.6.
T1 test.
So now we've got the test, that is okay. We can click on that.
Connect the dialyzer. Dialysis.
And here we've got the dialysis flow. Let's see where that fits. So now you've got the first part, and now you've got the dialysis flow. Remember, the dialysis flow, it connects on the side of the dialyzer, not above or below, but it connects on the side of the dialyzer. And here we've got, if you can see that there is water fluid coming in, you should see closely. Can you see the column going up? There. So you can see the column going up. So the dialyzer is now filling up with the water. This is the water which is coming. So you can see that the water is on the outer side while the blood is going to be on the inner side. So now this is going up to complete the priming process. Another important thing to remember, red goes with red, blue goes with blue. That's what you have to remember. So do not connect blue with red or red with blue. I think the machine is ready now. And here, I just wanted you to see 140 prescribed, and then you've got 140. So now you've got, the machine has set up all the things that we need. So even before you connect the patient, you can advise the machine what to do, and the machine is going to be directed in that way.
Sodium prescribed for conductivity, same page.
So there we are. So now what we've seen is how to prime a hemodialysis machine, how to connect the different connectors, what are the different kinds of sensors in these machines, what is the running of the pump. The pump is going to run as long as it can. And here we've got the ultrafiltration, how much we want to ultrafiltration. Now there we've got the ultrafiltration goal is 1 liter over a period of 4 hours. So that means we want to remove 250 ml per hour.
Blood flow rate 100 to 1000.
In this particular machine, we can have a blood flow rate from 100 to 1000. So that means we can have a very, very slow blood flow rate. Those people who are hypotensive, you want a very slow dialysis. And that's what you can do. So then you've got the dialysate flows, you've got the blood flows, and this is the standard dialysate flow is about 500. That is what we keep as the standard dialysate flow. If you want the patient to have more clearance, you can increase the dialysate flow to greater than that, to about 800. The older version of machines, they had 2 dialysate flows. They had a 500 dialysate flow, they had an 800, and I think they had probably one which was less than 500 as well. This is a blood flow, we can go up to 500. Obviously that is not really advised, and we can go low as well. So the maximum blood flow that we can get from this machine is 500 ml per minute, but that's really, really high. But the standard one is about 250, 280, about 300 for a safe dialysis procedure. So there we are. I hope that this bit was clear as to how to prime a dialysis machine and how it works. And hopefully now we'll be going on live patients in future videos to tell you how to needle a fistula, how to use a permanent dialysis catheter, and then further on the various complications that we can see in a dialysis session. Thank you very much, Mehmood. Thank you.